Imagine this scenario. It is the year 2035. The location is the airspace over the South China Sea. An American F-22 Raptor, the undisputed king of air superiority for the last 3 decades, is patrolling the skies. It is invisible to radar, agile beyond belief, and lethal. But suddenly its sensors scream a warning. It's not being targeted by another jet. It's being swarmed. Dozens of small, high-speed bogies appear from nowhere, overwhelming the Raptor's targeting computer. Before the pilot can even maneuver, the realization hits. The hunter has become the hunted. The F-22 Raptor is a marvel of engineering. It has never been defeated in air-to-air combat. It is the pinnacle of 5th-generation stealth technology. And yet the United States Air Force is actively trying to send it to the scrapyard. Why? Why would the Pentagon retire the most dominant fighter jet the world has ever seen? The answer lies in a secret program that has been developing in the shadows for years. A program so advanced, so complex, and so expensive that it makes the F-35 look like a budget toy. This is not just a new airplane. It is a complete reinvention of aerial warfare. It is the Next Generation Air Dominance Program, or NGAD. And it is here to prove that being the best pilot in the best jet is no longer enough. The future belongs to the machine that brings an entire army with it. Today, we are going deep into the black budget world of the U.S. Air Force. We are going to reveal why the F-22 is dying, what exactly the NGAD system of systems is, and the terrifying new technologies, from adaptive engines to laser weapons, that will define the 6th generation of air power. Welcome to the future of war. To understand why we need NGAD, we first have to understand why the current generation, the 5th generation, is failing. Don't get me wrong, the F-35 Lightning II and the F-22 Raptor are incredible machines. But they were designed for a different era. The F-22 was conceived in the 1980s to fight the Soviet Union in Europe. The F-35 was designed in the 1990s as a multi-role striker for a post-Cold War world. But the strategic board has changed. The threat is no longer a Soviet MiG over Germany. The threat is the vast, open expanse of the Pacific Ocean. And in the Pacific, physics is the enemy. The biggest problem facing the U.S. Air Force today is range. The combat radius of an F-35A is roughly 670 nautical miles. The F-22 is even shorter. In a conflict in the Pacific, or air bases in Guam or Japan could be destroyed by ballistic missiles in the opening hours of a war. American fighters would have to fly from bases thousands of miles away, perhaps from Australia or Hawaii, relying heavily on aerial refueling tankers. This creates a deadly vulnerability. If the enemy, let's say China with its J-20 Mighty Dragon, can shoot down the tankers, the F-22s and F-35s fall into the ocean without ever firing a shot. They are tethered by their fuel tanks. Furthermore, stealth is not an invisibility cloak, it is physics. Current stealth aircraft are optimized to defeat high-frequency engagement radars, the kind used by missiles to lock onto a target. But they are not invisible to low-frequency search radars. As computing power increases, adversaries are finding ways to network these search radars together to track stealth jets. The heat signature of current engines is also a massive liability. In the infrared spectrum, a jet engine is a burning torch in a dark room. The F-22 cannot be upgraded easily to fix these issues. Its avionics architecture is old. It lacks the internal fuel volume for long-range missions. It is a thoroughbred racehorse trying to run a marathon. The Air Force realized that putting more money into the Raptor was a diminishing return. They needed a clean sheet. They needed something designed specifically to dominate the tyranny of distance in the Pacific and to survive in an environment where stealth is degrading. They needed NGAD. So, what exactly is NGAD? If you are picturing a single, sleek, futuristic jet fighter that looks like a spaceship, you are only seeing 10% of the picture. The Air Force officials keep repeating a specific phrase, system of systems. NGAD is not a plane, it is a family. At the center of this family is the manned platform, often referred to as the PCA, or penetrating counter-air. This is the 6th generation fighter jet that a human pilot will actually sit in. But unlike the F-22, This pilot isn't just a dogfighter, he is a battle manager. He is the quarterback of the sky. Surrounding this manned fighter is the real revolution, the CCAs, or Collaborative Combat Aircraft. These are advanced autonomous drones, often called Loyal Wingmen, that fly alongside the manned jet. Imagine a formation flight. In the center, you have one manned NGAD fighter. Flanking it are 4 or 5 CCA drones. These drones are not just remote-controlled planes. They are powered by advanced artificial intelligence. They can take orders, but they execute them independently. One drone might be equipped as a sensor node, flying miles ahead to scan for enemy radar emissions, taking the risk so the human pilot doesn't have to. Another drone might be a weapons truck, carrying extra air-to-air missiles that the manned fighter can command to fire. A third drone might be an electronic warfare jammer, blinding enemy defenses. And in a worst-case scenario, a drone can act as a shield, flying in front of an incoming missile to sacrifice itself and save the human pilot. This changes the math of war entirely. In a traditional dogfight, if you have 2 F-22s against 4 enemy jets, when you are outnumbered. But with NGAD, 2 manned fighters bring 10 drones with them. Suddenly it's a 12 versus 4 fight. You are not just buying a better plane, you are buying mass. You are bringing volume to the fight. This architecture also solves the cost problem. We cannot afford to lose a $150 million manned fighter, but we can afford to lose a $10 million drone. The CCAs are designed to be attritable, meaning they are cheap enough that losing one is painful, but not catastrophic. This allows the U.S. Air Force to take risks that were previously impossible. Now let's talk about the hardware, because even the manned component of NGAD is going to be a technological monster. The most critical breakthrough that makes this long-range dominance possible is the engine. For decades, jet engines have been a compromise. You have turbofans, like on a commercial airliner, which bypass a lot of air around the core. They are fuel efficient and great for cruising long distances, but they lack the raw thrust and speed for supersonic combat. Then you have turbojets, like on a fighter, which push all the air through the core. They give you incredible speed and power, but they drink fuel like there is no tomorrow. The NGAD will be powered by something that breaks this compromise, the adaptive cycle engine. Companies like General Electric and Pratt & Whitney have been testing these engines under the Next Generation Adaptive Propulsion (NGAP) program. The concept is genius. The engine can physically change its internal geometry in mid-flight. When the pilot needs to cruise for thousands of miles across the Pacific to get to the battle zone, the engine opens a third stream of airflow, essentially turning itself into a high-efficiency turbofan. This increases range by up to 30% and heat dissipation by a massive margin. But the moment the pilot enters combat and needs to burn away from a missile, the engine closes that third stream, reverting to a high-thrust turbojet mode for maximum performance. This is the holy grail of aerospace engineering. It gives a fighter jet the legs of a bomber and the sprint speed of an interceptor. It means the NGAD fighter can take off from Hawaii, fly deep into enemy airspace, fight in return, all without being as reliant on vulnerable aerial tankers. But range is useless if you get shot down. This brings us to the next leap, broadband stealth. As I mentioned earlier, current stealth is optimized for high-frequency fire control radars. The NGAD is rumored to feature a tailless design. Think of a mini B-21 Raider bomber, but faster. By removing the vertical stabilizers, that's the tail fins, you eliminate the biggest radar reflectors on an aircraft. This design is incredibly unstable aerodynamically and requires insane computing power just to keep flying straight. But it offers all aspect stealth. It makes the plane nearly invisible, not just from the front, but from the sides and rear. And crucially, it is far more effective against those low-frequency search radars that threaten the F-22 and F-35. But stealth and speed are defensive. How does NGAD fight back? This brings us to the most sci-fi aspect of the program, directed energy weapons. For over a decade, the Air Force Research Laboratory, AFRL, has been working on Project Shield and Lance. The goal is to mount a high-energy laser pod onto a fighter jet. Why lasers? Think about the limitation of a standard fighter jet. An F-22 carries about 6 to 8 missiles internally. Once those missiles are gone, the pilot has to go home. In a saturated environment with hundreds of enemy drones and missiles, 8 shots are not enough. A laser, however, has what military planners call a deep magazine. As long as the engine, specifically that adaptive cycle engine we discussed, can generate enough electricity, the laser can keep firing. On the NGAD, lasers likely won't be used to dogfight other jets immediately. Their primary role will be active defense. Imagine an enemy J-20 fires a PL-15 long-range air-to-air missile at the NGAD. Instead of relying on chaff, flares, or violent maneuvers to dodge it, the NGAD's computer tracks the incoming missile, locks a laser beam onto its seeker head, and fries its electronics or physically burns through its casing in a fraction of a second. This transforms the fighter from a vulnerable target into a flying fortress. It allows the NGAD to operate deep inside enemy territory, shrugging off incoming attacks while its Loyal Wingman drones hunt down the enemy launchers. However, all this technology comes at a cost, a staggering cost. Frank Kendall, the Secretary of the Air Force, dropped a bombshell when he revealed the expected price tag of a single-manned NGAD fighter. He stated it would cost multiple hundreds of millions of dollars. Experts estimate roughly $300 million per airframe. To put that in perspective, one F-35A costs about $80 million. One NGAD costs nearly 4 times as much. For the price of one NGAD, you could buy 3 F-35s and still have money left over for a lifetime supply of fuel. This astronomical price tag has sparked a massive debate within the Pentagon. Can the U.S. Air Force afford a fleet of these jets? Originally, the plan was to buy around 200 of them to replace the F-22 one-for-one. But with budget constraints and the rapid evolution of AI, the Air Force recently announced a pause to reevaluate the design. This is the drama happening right now behind closed doors. There is a faction that believes the manned jet should be cheaper and lighter, relying even more on the drones. There is another faction that wants the gold-plated superfighter that is invincible. And then there is the contractor war. Lockheed Martin, the builder of the F-22 and F-35, and Boeing are the likely finalists battling for this contract. The winner secures the future of American combat aviation for the next 40 years. The loser might be pushed out of the fighter jet business forever. The stakes couldn't be higher. So, why build it? Why spend billions on a program that is so expensive and technically difficult? Because the alternative is losing air superiority. China is not standing still. Their J-20 is being produced in massive numbers. They are already testing their own 6th-generation concepts, rumored to be tailless designs similar to NGAD. The F-22 Raptor held the line for 20 years. It was the deterrent that kept rivals in check. But deterrence only works if your enemy believes they cannot win. If the U.S. Air Force sticks with the status quo, that belief starts to fade. NGAD is a statement. It tells the world that the United States intends to own the skies, not just by flying better planes, but by changing the definition of what a plane is. It shifts the paradigm from man versus man to network versus network. As we look at the sleek alien concepts of the NGAD, we have to ask ourselves a profound question. Is this the end of the line for human pilots? The NGAD is designed as a manned-unmanned team. The pilot is still there, but his role has shifted from stick and rudder flying to command and control. As AI gets better, faster, and fearless, the need for a biological pilot inside the cockpit diminishes. The G-force limits of a human body, 9 Gs, hold the machine back. A drone can pull 20 Gs. A drone doesn't get tired. A drone doesn't have a family waiting at home. The next generation air dominance fighter might be the most advanced machine ever built by human hands. But it might also be the last generation where a human is sitting in the driver's seat. It is the bridge to a future where war is fought entirely by algorithms and steel. The F-22 is retiring, the NGAD is rising, and the sky will never be the same again. If you enjoyed this deep dive into the future of military aviation, make sure to hit that subscribe button. We are tracking the NGAD program closely, and as soon as the winner of the contract is announced, you'll see it here first. Now, I want to hear from you. It's the debate of the century. In a hypothetical one-on-one battle, do you think the sheer numbers of the F-35 fleet are better? Or is the technological supremacy of a single $300 million NGAD worth the cost? Let me know in the comments below. Are you team quantity or team quality? Thanks for watching, and stay tuned for more.